Hello dear students, welcome to mathematics class. In this class, let us discuss some more examples on analytic function. So here it is the example. If f of z is analytic in an open set S and f dash of z equal to 0 for all z belongs to S, then show that f of z is constant. So here it is given that f of z is analytic, means the function of the complex variable f of z is satisfying the CR equations in the set S, and also f dash of z equal to 0, means the first order derivative of the function is 0, then we need to show that f of z is constant. So here f of z is constant means it is independent of the variables, because constant means let us consider k as a constant, means it is independent of the variables x and y. So therefore here we need to prove that f of z is independent of x and y. Let f of z is equal to u plus iv, where u is the real part of the function and v is imaginary part of the function. And we know that now f dash of z, that is dou u by dou x plus I into dou v by dou x, right. Now given that f dash of z is equal to 0, so now it implies dou u by dou x plus I into dou v by dou x equal to 0. So therefore dou u by dou x equal to 0 and dou v by dou x is also 0, because a complex variable here x plus iy is equal to 0. So if x plus iy is equal to 0, then its real and imaginary parts both are equal to 0, then only a complex variable is equal to 0. So therefore here it is a complex variable dou u by dou x plus I into dou v by dou x, and it is equal to 0 means the real and imaginary parts of the complex variable are equal to 0. Since f of z is analytic, so therefore CR equations satisfied, right. It is given that the function is analytic. So if the function is analytic, then CR equations satisfied for that function. So CR equations are dou u by dou x is equal to dou v by dou y and dou u by dou y equal to minus dou v by dou x. So therefore dou u by dou x is equal to dou v by dou y, which is equal to 0, because already we know that dou u by dou x equal to 0, and dou u by dou y is equal to minus dou v by dou x, which is equal to 0. So means dou u by dou y equal to minus dou v by dou x, and we know that dou v by dou x equal to 0. So therefore it is also equal to 0. It implies that u and v, because the partial derivatives with respect to x and y of u and v are equal to 0, means the functions u and v are independent of x and y. So it implies that u and v independent of x and y. So it implies that if these two functions are independent of x and y, means, so here x and y are the variables, right. If any function is independent of variable, means it is a constant. So it implies that u and v are constants. So if u and v are constants, then the sum of u and v is nothing but f of z. So therefore that f of z is also constant. Therefore f of z is constant. The next example is f of z is analytic function such that f of z is always real, then show that f of z is constant. So here given that f of z is analytic, hence it satisfies CR equations, and one more condition is given that f of z is always real. So f of z is real means it has imaginary part is equal to 0, because a complex number z equal to x plus iy, a complex number z equal to x plus iy is real if y is equal to 0. So if y equal to 0 means if the imaginary part of the complex number is equal to 0, then every complex number is purely real. So now here it is given that f of z is real. Now let f of z equal to u plus iv is analytic. So let us consider f of z equal to u plus iv as an analytic function, and given f of z is real. So if the function is real function, it has imaginary part is equal to 0. So therefore it implies that v is equal to 0. Now v is equal to 0 means its partial derivatives with respect to x and y, they are also equal to 0. So here it implies that dou v by dou x equal to 0 and dou v by dou y is also 0, right? Since the function itself is 0 means its derivatives are also equal to 0. And now by CR equations, because the function is analytic, hence the CR equation satisfied. So therefore we can use the CR equations here. So CR equations are given by dou u by dou x equal to dou v by dou y, and it is equal to 0, because dou v by dou y is always, or already it is 0 since v is equal to 0, and dou u by dou y is equal to minus dou v by dou x, it is also equal to 0 because dou v by dou x is also 0. So therefore all the partial derivatives are 0. It implies that u is also independent of x and y, because u and here the v is already 0 and u is not changing with respect to x and y, means differentiation means the function is changing with respect to x or y, but here dou u by dou x and dou u by dou y are equal to 0 means the function is not changing with respect to x and y, means it is not depending on the variables x and y. So since it is not depending on x and y means it is independent of x and y. If any function is independent of x and y, hence it is constant. So here u is independent of x and y means u is constant. So here in the function f of z equal to u plus iv, so already v is equal to 0, then remaining f of z equal to u, and u is constant means the function f of z is also constant. So here since f of z equal to u, Therefore, f of z is constant, hence the proof. So, here we have proved that an analytic function which is purely real, then it is a constant function. The next example is, show that analytic function with the constant imaginary part is constant. So, here function is analytic and imaginary part of that function is constant, means v is constant here. So, here let us consider the function. Let f of z equal to u plus iv is analytic. Analytic means CR equations satisfied for the function f of z, and given that imaginary part is constant, that is v is constant. So, let v is equal to some constant k. So, if it is constant, then the derivative of that function with respect to x is 0, and also dou v by dou y is also 0, because the derivative of the constant function is always 0. It may be with respect to x or y. Now, since f of z is analytic, CR equations satisfied. So, if the CR equation satisfied, then dou u by dou x equal to dou v by dou y is equal to 0, and dou u by dou y equal to minus dou v by dou x equal to 0. So, therefore, the derivative of the function with respect to, or the derivative of the real part u with respect to x and y is equal to 0, means u is independent of x and y. So, here all the 3 examples are similar, because in the first example we have proved that if f dash of z equal to 0, then the function is constant, and in the second example, if f of z is real, means there is no imaginary part, then also function is constant. If imaginary part is constant, then the function is constant. So, therefore, here u is independent of x and y, therefore, u is constant and v is already a constant. So, in the function f of z equal to u plus iv, if both of them are constants, then f of z is also constant. So, it implies that f of z is constant. Now, show that dou of u comma v divided by dou of x comma y is equal to mod of f dash of z whole square if f of z equal to u plus iv is analytic. So, here we are using 2 concepts. So, one is Jacobian, which is already you came across that Jacobians, and one more point is modulus of a complex number. So, if z equal to x plus iy is a complex variable, then mod z is nothing but square root of x square plus y square. Then mod z whole square equal to x square plus y square. So, this is called as modulus of the complex number, means square root of square of real part plus square of imaginary part. So, it is called as modulus of the complex number. Then square of that is equal to what? Mod z whole square equal to x square plus y square. So here we already know that what is f dash of z. So I know that f dash of z equal to what? Dou u by dou x plus I into dou v by dou x. Then what is mod of f dash of z? It is square root of dou u by dou x whole square plus dou v by dou x whole square, right? Then square of this one means that is dou u by dou x whole square plus dou v by dou x whole square. That we need to prove. Now let f of z equal to u plus iv is analytic, and f dash of z, that we already know the formula for f dash of z, that is dou u by dou x plus I into dou v by dou x. Then mod of this one, mod of f dash of z is equal to square root of dou u by dou x whole square plus dou v by dou x whole square. Then square of this one, that is mod of f dash of z whole square equal to dou u by dou x whole square plus dou v by dou x whole square, means squaring on both sides, and consider this as first equation. So here we have considered f of z and f dash of z, modulus of the function, then square of that modulus. Now consider dou of u comma v divided by dou of x comma y. So here this can be written as determinant of dou u by dou x, dou u by dou y, it is dou v by dou x, dou v by dou y. So by using the Jacobians we have written this one. Now by using CR equations we can make some changes in this determinant. So here let us consider dou u by dou x as it is, and now dou u by dou y can be replaced by minus dou v by dou x, right, by CR equations, and dou v by dou x as it is, and dou v by dou y is equal to dou u by dou x. So here since or by CR equations we have made some changes in that Jacobian. Now expand this 2 cross 2 determinant. So already know how to expand. Now dou u by dou x into dou u by dou x, that is equal to what? Dou u by dou x whole square minus that is it is in the formula only, and now dou v by dou x into minus dou v by dou x is equal to what? Minus dou v by dou x whole square. So minus into minus becomes plus dou v by dou x whole square, and it is equal to what? Dou of u comma v divided by dou of x comma y, and consider this as second equation. So now look at equations 1 and 2. So here it is also dou u by dou x whole square plus dou v by dou x whole square, here also same. So therefore from equations 1 and 2, from equations 1 and 2 we get dou of u comma v divided by dou of x comma y is equal to mod f dash of z whole square. So hence the result. So here we have used the modulus of the complex number and definition of Jacobian.